Hi and welcome to onmaths Topic Busters. Have you ever felt like you're just going round in circles or constantly going off on a tangent? Well, today we're doing circle theorems. Enjoy! Hi and welcome to onmaths Topic Busters. So we're looking at circle theorems today. It's all about memory. You need to make sure that you absolutely know your circle theorems going into the test. You need to know them off by heart. You need to be ready to use them, ready to spot them. It's kind of like a Where's Wally book or something, trying to spot those circle theorems. There's a few tips. Have you got a radius? Have you not got a radius? Have you got a tangent? And there's triggers in the question that might guide you to the correct circle theorem. But you need to also know how to describe them. What are you going to write to say to the examiner, yep, I know what I'm doing, this is the reason. There are more marks now than ever before for the reasons. So you might think, oh, I got the right answer. Yeah, but you're only going to get maybe 2 out of the 5 marks for the actual answer. 3 of the marks are for the reasons. And if you think you can just learn the circle theorems and you're fine, not quite. You've got to know all the other bits, so vertically opposite angles, angles in a triangle, angles in a quadrilateral, etc, etc. Isosceles triangles come up a lot because a circle naturally will have a lot of isosceles, because if you've got 2 radii, there you go, you've got yourself an isosceles triangle. I hope you find this video useful. If you do, fantastic, let us know. Enjoy! So in these questions we're given some crudely drawn circles and we're asked to find x. So I'm going to start off with the first one. The most important thing to realise with this one is these 2 lines here are both radii. Therefore we have ourselves an isosceles triangle. Okay, so if I look at that triangle, if both of these ones are radii, then they must be equal length. Therefore if that's 50 degrees there, then this x must also equal 50 degrees. Now make sure you write down the reason. The reason is it's an isosceles triangle. Now I'm not going to be writing down the reasons because it will take too long, okay, but make sure you write down the reason as well. The marks on these types of question will always be for the reasons as well, and actually they've increased the marks for the reasons and decreased the marks just for writing the correct number. So the reason for that is it's an isosceles triangle, so they're the same. Right, the next one is our first circle theorem, and the theorem states that when you've got a point going, 2 lines going to the centre and to the circumference from 2 points, and I've highlighted these in purple. So from those 2 purple points we've got an angle at the circumference and we've got an angle at the centre. Okay, the theorem says that the angle at the centre is twice the angle at the circumference. Going the other way around, that basically means that x is half of the angle at the centre. So x here would be 50 degrees. And the reason is that the angle at the centre is twice the angle at the circumference. The angle at the centre is the one in green, the angle at the circumference is the one in blue. Now, following that, we've got exactly the same situation in the last point. We've got 2 points on the circumference. We've got an angle at the centre, and we've got an angle on the circumference. This time the angle at the centre is 180 degrees. Okay, and that's a diameter that we've drawn between the 2 purple lines. So therefore x is going to be 180 degrees divided by 2, which is 90 degrees. And this actually is a circle theorem in itself. An angle in a semicircle or an angle from a diameter is always going to be 90 degrees, because angle at a diameter is going to be 180 degrees, so the angle at the circumference, on the circumference will be 90 degrees. So whenever you've got a situation where you've got an angle coming from a diameter, it's always going to be 90 degrees. Okay, have a go. Okay, so in this first question, obviously it's an isosceles, but we're given the 40 degrees here, and we're asked for the top angle. So if I write this out the right way up, or draw this out the right way up, then we're given this is 40 degrees. It's an isosceles like that, but we're asked for this one. So this one here would be 40 degrees. So in total it would be 80. So to find x, we do 180, because angles in a triangle, take away 2 lots of 40, so take away 80. So x is 100 degrees. Now, you need to write down 2 reasons now. So the first reason is it's an isosceles, so therefore the bottom 2 angles are the same. And the second reason is angles in a triangle add up to 180. Right, the next one. Now this is the same situation as the example we had before. This is exactly the same as angle at centre is twice the angle at circumference. It's just this angle at the circumference has just shifted around about here. But this one here and this one here are going to be exactly the same. So therefore, to find x, we just do 30, the angle at the circumference, times 2. Because x is at the centre, so we double 30, and the angle at the centre will be 60 degrees. Okay, last one. So we know this is 180 degrees here, so therefore that's 90. And the circle theorem for that would be angle in a semicircle is 90 degrees, or angle from a diameter is 90 degrees. If this is 90 and this is 20, to find x we do 180 take away 90 plus 20. 180 take away 110, so therefore x is 70 degrees. And the reasons for that is obviously angles in a semicircle, angles from a diameter, and then angles in a triangle add up to 180. Okay, on to the next circle theorems. So this first one is another circle theorem. Basically, if you have 2 points coming off 2 points on the circumference, so 2 angles coming off 2 points in the circumference, then the angles are always equal. So that x is 30 degrees as well. So if they're coming from the same 2 points, they will be equal. And we often call it a whole load of different things, but the most common one is angles from the same chord, or angles from the same arc. I use angles from the same chord. So basically, if you imagine you draw a chord between those, both those angles are coming from it. So angles from the same chord are equal is the reason for that. And remember, I'm not writing down the reasons, but you do need to write down the reasons to get the marks. Okay, the next one. This is quite a funny one because we have what's called a cyclic quadrilateral, which is just a fancy way of saying a 4-sided shape with all 4 points touching the circumference. And the rule is that the opposite ones, so this one and this one, are not equal, but they add up to 180. So x is going to be 180 take away 55. So 180 take away 50 is 130, take away 5 would be 125. Okay, degrees I should write. And the reason for that, all you need to do is write down cyclic quadrilateral, or opposite angles in cyclic quadrilateral adds up to 180. Cyclic quadrilateral sometimes is enough, but if you remember, just write down the whole thing. You won't lose marks for writing too much. Okay, the last one is quite a specialised one. It doesn't come up that much, but it is one that you do need to learn. Basically, if you have a situation where you've got a line coming down, this line here coming down, and hitting a chord, which is just a diameter that doesn't go through the centre, okay, hitting a chord at 90 degrees, so it's perpendicular, and I can see the little 90 degrees here, then it will create 2 equal side lengths on either side. Okay, so we can work out what the left hand length is. If I remove that 6, if the whole thing is 6, then we know this bit here will be 3 centimeters, because the whole thing's 6, it's going to be halfway. And then we're left with a nice, hopefully nice, right angle triangle, where we know this one, and we're trying to find that one. So we're going to do 5 squared take away 3 squared. You can do it with the working out. So 25 take away, and obviously square rooted, 25 take away 9, root 16, x equals 4 centimeters. And you might just know it as a 3, 4, 5 triangle. Fine. Just make sure you write down the reason. And now the reason is that when we have a line coming down from the center bisecting a chord, then it cuts the line into half, so the line either side are equal length. Yeah, it's a bit of a mouthful, that's probably why it doesn't show up that much. Okay, have a go. Okay, so in the first one we've got to identify, first of all, I would probably focus on this one. This is going to be 30 degrees because it's angles from the same chord. Okay, this time we're looking at the two angles coming from these 2 points, so we're going downwards for it. Then I need to identify what this angle here is. Now that's going to be 50 degrees because they're vertically opposite angles. This is vertically opposite, so if I highlight the vertically opposite angles, this one and this one are vertically opposite. And then to work out x, we're going to do 180 take away 50 plus 30, which is 100 degrees. So the reasons you need for this one are angles from the same chord and vertically opposite angles and angles in a triangle, and you need to make sure you get all 3 of them to get the mark. Now what you might have done is just move the x over here, because we know that these two will be the same, because if we take the 2 points as this one and this one, then x will be the same at the top, and that's absolutely fine method. And you only need to do 2 reasons. You just need to say angles from the same chord, this time talking about this bottom chord here, and then angles in a triangle, so you take away the 30 and the 50. You get the same answer, just different method. And you'll find with circle theorems there are different methods sometimes, so don't just think you're wrong if you don't get the same method as someone else. Okay, this second one, these two are opposite angles in a cyclic quadrilateral. So we know that x plus 2x will equal 180 degrees because opposite angles in a cyclic quadrilateral add up to 180. So 3x equals 180. Do your lines, so times 3, so we got to get rid of it by dividing both sides by 3. X equals 60 degrees. Perfect. And sometimes you'll need to use algebra in this way, and that's absolutely fine, so just do it as you would normally. Okay, this last one, we know that these 2 lines are equal, therefore if I can rub off that 10 and change it to a 5 over here, that's absolutely fine. Now this time I've been sneaky because I've just put a radius down at the bottom, but obviously the length of a radius is always the same, so that's also going to be 13 centimeters here. If I draw out that right angle triangle, try and figure out which way to put it, probably this way is best. Okay, so we've got 13 centimeters here, we've got 5 at the bottom, we've got x here, it doesn't matter which way around you have them. So we're going to do 13 squared take away 5 squared, just use normal Pythagoras, and I believe that would be root 144, which x should therefore equal 12 centimeters. Okay, so we must be coming to an end of these circle theorems. All of these circle theorems are to do with tangents, so I've done one mega tangent going through them. So we're going to start with the red one. So this is really simple. Basically, whenever you have a tangent, which we have on the graph, and the tangent's just a line that touches the circle once, and you have a radius touching it, then x is going to be 90 degrees. And the reason for that is you just say angle between tangent and radius equals 90 degrees. It's that simple. I'm going to go to the yellow one next. Now the distance I'm showing with this is the distance between where the points intersect, where the two tangents intersect, and where they touch the circle. And this theorem just says that the distance is the same. So x is going to be 10 centimeters. So if it's 10 centimeters at the bottom between where the two tangents intersect and where it touches the circle, it's going to be 10 centimeters where x is. The last one, and the reason this is green is because it's a grade higher than the other ones, so this is the fancy one. Now, x is going to equal 50 degrees, and the reason for that is whenever you have a triangle coming from a tangent, which we do in this one, then the opposite angle in the triangle will be equal to the angle between the triangle and the tangent. Yeah, you can see why it's a higher grade. They only accept 3 words as a reason for this one as well, and that is alternate segment theorem. And I might even write that down. Alternate segment theorem. I said I wouldn't write any of these down, but this is such an important one. I don't know why I've capitalised the other two. I don't know why I've capitalised any of them, but anyway. So you need to write down those 3 words, alternate segment theorem. And the way of spotting this one is if you have a tangent and you don't have a radius coming from it, you need to be thinking alternate segment theorem. Now, they do use alternate segment theorem and they also have a radius coming from it. But if you do enough practice of these questions, you kind of get an instinct for what they're trying to get at with these questions. Okay, have a go. Okay, so on this first one, first thing to notice is obviously this is a right angle triangle, and the reason for that is the angle between a radius and a tangent is 90 degrees. And then we work it out by using Pythagoras, so 5 squared minus 4 squared, blah blah blah, root 9 equals 3. Okay, so x is 3 centimeters. Now for the yellow one, we know that these two are the same, these two lengths are the same, because the distance between where two tangents intersect and where they touch the circle is equal. We know these two are the same because they are radii, and we know these are right angles here, and we know these two lengths are the same because they're the same line. So those two triangles that we have, the one at the top, one at the bottom, are congruent, which means they're identical. So every angle, every length, everything's the same. Therefore, we know that this angle here is also going to be 30 degrees. So to work out x, we do 180, angle in triangle, take away 30 plus 90. Those are the two that we know. Then when we do that, we hopefully get the answer of 60. So x equals 60 degrees. Now make sure you write down all the reasons for that. The biggest reason to write down is the fact that those two triangles are congruent because of the radius being the same and the tangent length being the same. Okay, and angles in a triangle as well. Make sure to write that down. So normally the mark scheme gives you a mark or a couple of marks for the circle theorems, and then a mark or so for other reasons like angles in a triangle. Okay, this last one all hinges on this angle here. This is your master angle. This is the key angle to work with. Now there's two ways of doing this. You can either transport x up to this purple angle because of alternate segment theorem, or you can work out what this angle is and then work out x with it. So I'm just going to work out what this angle is. So angles in a triangle add up to 180. So we're left over with 100. And x equals 100 degrees because of alternate segment theorem. And there is no other way of getting the marks for the reason for that. It's those three words, alternate segment theorem. Okay, have a go at these questions. Okay, so we're going to start off with the red one. The red one, you need to find this angle here first, and you do that because angles, opposite angles in a cyclic quadrilateral add up to 180. So this one's going to be 80 because the one opposite is 100. And then we notice that we've got two angles coming from the same chord. We've got the angle, we've got an angle at the center, and we've got an angle at circumference from the same chord. So x is going to be twice as big as the 80. So here's the angle at the center, and here's the angle at the circumference. So x is going to be twice as big. So x for this one is going to be 80 times 2, which is 160 degrees. So there is another way of answering this question. So if you've got 160 degrees another way, but the two circle theorems that I've used are opposite angles in a cyclic quadrilateral add up to 180, and the angle at the centre is twice the angle at the circumference. Okay, on to the yellow one. Yellow one, we're using not a circle theorem, but the fact that this is an isosceles because there's two radii. Therefore, if the top one's 100, these two here are both going to be 180 take away 100, and then half of that because they're equal. So they're both going to be 40. These ones here, and we also know that the complete green angle that I've put on is 90 degrees because angle between a radius and a tangent is 90 degrees. So to work out x, it's going to be 90 degrees, which is the total angle. Take away the bit we don't want, so take away the 40, so that's going to be 50 degrees. Okay, last one. We know these two lengths are equal. Okay, that's not of interest, but we know that these are both 90 degrees. Here we've got a quadrilateral, and we've got 90 degrees here, we've got 90 degrees here, and we've got 180 degrees at the top. So simply to work out x, you do 360, take away, and then 90 plus 90 plus 80 degrees. So the only circle theorem we need here is, again, the angle between a tangent and a radius is 90 degrees. You don't need another one. You could have split in half and done that way, but there's just no need. So to find out what x is going to be 100 degrees. Thank you very much for watching this Topic Busters. If you enjoyed this one and want to see more, please look at our YouTube account. Just type in onmaths on YouTube and we come up. Otherwise, go to the website onmaths.com and you can have a go at all of our predictions, Topic Busters, demon questions, mini mocks, and countless other things. Thank you very much.